Hello students, hope you enjoyed learning about computers and problem solving methods. Having seen everything about the working of computers, various problem solving aspects and structured programming concepts and paradigms like top down approach and bottom up approach, let us delve into one of the programming languages which is of bottom up nature. In this module and in forthcoming modules, we are going to learn and explore how we can solve computer problems using Python. During 1990s, Guido van Rossum at National Institute for Mathematics and Computer Science, Netherlands, wanted to develop a language that is short and unique. He named this new language Python after a BBC's comedy show named as Monty Python's Flying Circus. Python is a high level general purpose programming language. It is an interpreted, interactive, object oriented programming language which is very simple and uses English like word. One question that might have aroused in your mind is, why should I learn Python when there are so many programming languages? Is Python worth learning? Job market identified the key reasons why should you learn Python today. Python had a great year in 2016. It is ranked as the 6th popular language by Stack Overflow Developer Survey and ranked as 4th most wanted technology of the year. It is the 2nd most popular programming language in the world based on the popularity of programming language index. So, why the hype? What makes Python so popular? On one side, it may just be a matter of individual preferences, but there are a set of features which made this language more popular and attractive. Let me briefly enumerate the features of Python. Simple. Python is a simple language. This means that understanding a program written in Python is almost like reading English. Easy to learn. Python programs are very simple and use a few keywords and are clearly defined syntax. Hence, this makes language Python easy. Third comes object oriented. Python extends its support to both object oriented and structured programming styles. Python is a powerful language for implementing object oriented concepts like classes and objects, encapsulation, inheritance, etc. It also supports building programs using function, that is structure programming. Then comes interpreted. Python is an interpreted language, that is the programs written in Python are processed at runtime by interpreter. It is not needed to compile the program, you can merely run the program. A Python interpreter converts the source code into an intermediate code called bytecode like Java. These bytecodes are then translated into native language of the computer for execution. Then high level language. Python is considered a high level programming language because it relieves us from worrying about the low level details like memory management. Assembly language used to provide the commands to the CPU. Then extensive support of libraries. Python has a huge collection of built-in functionalities called libraries. These libraries are portable across different platforms. Then interactive. Interactive Python is very much helpful for debugging purpose. You can directly interact with the interpreter at the Python prompt. In this mode, Python is used like the Unix terminal. Portable. Python's platform independent nature makes it portable, that is it runs on all platforms. Then multi-threaded. Executing more than one process of a program is called multi-threading. This nature is well supported by Python. Python has advantageous features and programmers prefer Python over other programming languages because it is easy to learn and code. However, this language has still not made its place in some computing domains. Therefore, this language may not solve some of the enterprise solutions, and limitations include speed. Since it is an interpreted language, Python is slower when compared to C or C++. Even though it is high level language, unlike C or C++, it is not closer to hardware. Then Python is not a good choice for mobile development. The developers cannot use Python directly for developing mobile applications, but frameworks like Kiwi have to be used to build cross-platform mobile applications and other multi-touch application software with user interface using Python. Next, Python is not a good choice for memory intensive and computational intensive tasks. Due to the flexibility of the data types, Python's memory consumption is also high. Finally, we have runtime errors. Python programmers noticed several issues with the design of the language. Python is a dynamically typed programming language. This means that it does not require users to declare the type of variable before using them. This feature makes the user to write code freely, but a number of errors merge at the time of compilation as the variable types are not defined explicitly. So, the developers must perform a number of tests additionally to identify and fix the bugs during runtime. Then, Python provides no support for block commands. Now, you might have a question, what exactly can I use Python for? There are wide range of application for Python. First one is, it can be used as a scripting language. As a scripting language, Python allows us to write small scripts that can be used to automate simple tasks like cron tab in Unix. Then web development. Python has facility for integrating database and web development frameworks. Web frameworks that are based on Python like Django, Flask, Pyramid, etc. have recently become very popular for web development. These web frameworks help you create server-side code in Python and provide libraries which simply integration with database and various internet protocols like HTTP, FTP, POP, etc. Next, desktop applications. Due to its feature, Python is found to be suitable for developing desktop based GUI applications. To develop such applications, Python supports various GUI toolkits like WX widgets, Kiwi, Qt, WX Python. These toolkits provide high functional graphical user interfacing. Then comes computational applications. Python supports various tools that let it perform high computation and processing of data. The list of tools available include SciPy, a collection of packages for mathematics, science and engineering; Pandas, a data analytics and modeling library providing high performance, easy to use data structures; IPython, a powerful shell for easy editing and recording of work session. It also supports visualizations and parallel computing. NumPy, a package that lets us deal with complex numerical computations. It defines the numerical array and matrix types and basic operations on them. SymPy, a package for symbolic mathematics and computer algebra. Python finds its role in image processing applications also. Python supports variety of image processing libraries that implement algorithms and utilities for use in research, academic and industrial applications. Some of them include Scikit image. This library includes collection of algorithms for image processing. OpenCV, this is library for computer vision with Python interface. Simple ITK, it is library for medical image processing. At last, machine learning. There are popular machine learning libraries and frameworks for Python. Two of the most popular ones are scikit-learn and TensorFlow. Scikit-learn comes with some of the more popular machine learning algorithms built in. TensorFlow is more of low-level library that allows you to build custom machine learning algorithms. Apart from these applications, Python finds its uses in several cases such as audio or video based applications, 2D, 3D CAD applications, computer vision facilities like face detection and color detection, robotics, artificial intelligence, data analytics, which is the hottest of application in Python. So far, we have outlined the features, applications and limitations of Python. What's next? Of course, start working with Python. To work with, you need to install Python first. So, let us start. We have three ways to start with Python. The first way is running in interactive mode. Python in the command line will invoke the interpreter in interactive mode. You can directly type in Python expressions to get the output. Second way is the script mode. This mode is used to execute Python scripts written as files. Scripts can be saved to disk for future use. Python scripts have the extensions .py, meaning that they are Python scripts. You can use any text editor to create Python scripts. Then finally, we have integrated development environment, that is IDE with GUI. As the name implies, IDEs integrate several tools specifically designed for software development. These tools usually include an editor designed to handle the code, for example, syntax highlighting, auto completion. Then build, execution and debugging tools. Some of the commonly used Python IDEs are PyScripter, PyCharm, Spider. Now, let us see how to install Python on Windows. Python is available for most of the operating systems such as Windows, Linux, Mac, etc. The full list of new and earlier release can be found at www.python.org/downloads. Python 3.7.1 is the recent release. The Python 3.7 series is the newest major release of Python language and contains many features and optimizations. So, let us work with this version of Python. Let us enumerate the steps to install Python. First, download Python 3.7 from www.python.org/downloads. Go to the folder where the Python has been downloaded. You can see Python 3.7.1.exe. Double click on it to run. You can see a window as you are watching and click on run. After clicking run, you can see a window like what you are noticing now. Click on install now. Make sure that you have checked the add path 3.72 path. Path is an environmental variable in Windows. It basically tells the command prompt what folders to look for when executing a command. Make sure that you have checked the add Python 3.7 to path. Path is an environment variable in Windows. It basically tells the command prompt what folders to look for when executing a command. If you do not add Python to path, then you have to call Python from the command line as seen on the screen. Whereas, if you add it to path, you can do this. After clicking install now, you can see a window like the one shown on the monitor. Then click on Finish to complete the installation. Now go to Start and search for Python. You can see as given on the screen. Click on Python 3.7 32-bit to open Python interpreter. The interpreter has a 3 greater than prompt wherein you can enter Python commands and press enter. Now the interpreter executes the command and displays the result. An example is seen now. When you do these steps, Python ideally also gets installed. Shall we see how to start and use Python ideally? Python ideally is one more way to execute Python statements and commands in the interactive mode. This interactive mode is also called as shell. The steps to launch Python ideally are enumerated. Click on ideally Python 3.7 32-bit to open the Python 3.7.1 shell as shown over the screen. This is also called as an interactive shell. This shell has a 3 greater than prompt wherein you can enter Python commands and press enter key. Enter your commands at the prompt. An example is now seen on the screen. Instead of executing commands one by one at the prompt, you can write a sequence of instructions or commands in a file called as scripts and execute them at once. Let me list the steps to execute a script. In Python ideally shell, click on File, choose New File to open the text editor. Now you can see an editor as shown now. Type your Python code in the white space as shown. Save the script as shown now. Once you save the script, the file name can be seen above the menu bar as you are watching now. Run the script as shown now. Check for any error in the script. If so, correct them and run again. Now it is time to start learning Python programming. Computers do not understand natural languages like English, so we have programming languages that have structured form of instructions to process a variety of data. There is a huge list of programming languages for computers. One such language is Python. Let us explore in detail in forthcoming modules about Python. In this module, we will see basic Python elements. English has a defined characters that are alphabets. Like natural languages, any computer programming language will have a character set. First, let us see what characters make a character set for Python. A defined list of characters recognized by Python interpreter forms its character set. The characters are interpreted and identified as characters, variables, strings, constants, keywords, etc. The character set of Python includes. Next, we will see about tokens. What are tokens? Tokens are the smallest units of a program. The list of tokens include keywords, identifiers and variables, literals, operators and delimiters. Let us briefly describe the tokens. The first one is keywords. Like any other programming languages, Python also has a set of keywords, also called as reserved words. The keywords have special meaning and use. They cannot be used as identifiers. The list of keywords in Python can be seen now. Then comes literals. Literals can be defined as data that are given as variables or constants in a program. Python have literals like string literals, numeric literals, Boolean literals. String literals. A string is a set of characters. The literal value for a string is written by surrounding the value with single, double or triple quotes. Numeric literals. They are literal having digits from 0 to 9, an optional plus or minus and an optional decimal point. If a numeric literal have digits without a decimal point, then it is said to be an integer literal, otherwise it is a floating point literal. Examples of valid literals 12, minus 345, etc. Valid floating point literals are 123.01, 435.0, 467.0, minus 243.0, etc. Some invalid numerical literals include 5000.09 with comma separating the 1000 digit and 2567 with a comma separating 1000 digit. Another form of numerical literal is complex or imaginary literal. An imaginary literal yields a complex number with a real part of 0.0. Boolean literals. A Boolean literal has any of the two values, namely true or false. We will be discussing in detail about the literals in the forthcoming modules on Python literals and string. Next type of token is variables and identifier. Variable is a name which refers a memory location. Variables is also known as identifiers and used to hold values. In Python, you are not required to declare the type of variables as we do in languages like C, C++ and Java. This is so because Python is a type infer language and smart enough to understand. Variable names can be formed by grouping both letters, uppercase and lowercase and digits, but they have to begin with a letter or an underscore. Let us consider a Python statement. Flag is equal to 0, where flag is the name of the variable. It can be assigned different values in a program. Everything in Python is an object and every variable holds an object instance. When an object is initiated, it is assigned a unique object ID. Its type is defined at runtime and once set, it cannot be changed. Otherwise, a mutable object can be changed after its creation, whereas an immutable object cannot be changed. Objects of built-in types like int, float, bool, strings are immutables. Objects of built-in types like list, set, dictionary are mutable. Let us try immutable objects in Python shell. In Python, a variable can hold different types of values at different point of time during the execution of a program. Now, let us look into identifier. Identifier is the name used to call a particular entity in a program, which is not a keyword. Identifier particularly names a variable, function, structure, enum, class, etc. An identifier distinctly identifies an entity in a program while its execution. Two identifiers cannot have the same name in a program. Let me enumerate the rules for writing an identifier. The first character of an identifier must be an alphabet or an underscore. All the characters except the first character may be an alphabet of lowercase or uppercase or underscore or a digit. Identifier name must not contain any white space or special characters. Identifier name must not be same as keywords. Identifier names are case sensitive. For example, sum with small s and sum with capital S is not the same. A few examples of valid identifier include ABG1, sum underscore, underscore total, etc. Some examples of invalid identifiers are total, sum with space in between them, one sum plus, etc. Variable is one type of identifier. Other types of identifiers are function names, class names, structure names, etc. So, it can be said that all the variables are identifier, whereas vice versa is not true. Next type of token is operators. Operators are the symbols which perform the operation on operands. In Python, operators can be categorized as arithmetic operators, relational operators, assignment operators, logical operators, membership operators, identity operators and bitwise operators. We will discuss these operators in detail in the module exclusively meant for operators. Then finally, we have delimiters. A delimiter is one or more characters that separates a given string. Please see the list of delimiters in Python. Then what is next? Next, we are going to discuss about data types. Data that can be stored in memory can be of different types. For example, the year of birth of a person will be an integer, today's dollar rate is of float, name of the person is of string, etc. Python provides various standard data types that define the storage method on each of them. The standard data types defined in Python include numeric, string, boolean, list, tuple, dictionary. In this section, let us learn these data types along with examples. First and very common type is numeric. Numeric data types store numbers. Python creates number objects when a number is assigned to a variable. Numbers can be integer and real, also called floating point numbers, which may be both positive and negative. Python supports 4 types of numeric data. Integer. Integer include signed integers like 24, 6, 27, 29, 1997, etc. Long. Long integers used for higher range of values. Python allows us to use lowercase l to be used with long integers, but long is not supported from Python 3.0 onwards. Int will itself behave as long. Next type is float. Float is used to store floating point numbers like 29.24, minus 6.29, 15.2, etc. Finally, complex. Complex numbers like 3.12j, 21.0 plus 6.2j, etc. A complex number contains an ordered pair, that is x plus iy, where x and y denote the real and imaginary parts respectively. Next data type is string. String is a set of characters enclosed in quotes and used to store the text based information. Strings are stored as individual characters in a contiguous memory location. It can be accessed from both directions in forward and backward. A string can be accessed from both directions in forward and backward. A string can be declared as shown. The various string operations like concatenation, substring will be illustrated in the module on literals and strings. The third data type is Boolean. Python tree has another data type called Boolean data type. Objects of Boolean type may have one of the two values, namely true or false. Then comes list. Lists are useful data types in Python. A list can contain a set of values of different types. List variables are declared by using brackets, square brackets. Allow list variables are declared by using square brackets following the variable name as shown now. Let us discuss on list in detail later in forthcoming module. Then we have tuple. Tuple is an ordered sequence of items same as list. The only difference is that tuples are immutable. Once created, they cannot be modified. It is defined within parentheses where the items are separated by commas. Let us see an example for creating a tuple. Again, tuples will be discussed in detail later. To conclude, in this module, we started with the history of Python along with its features, advantages and limitations. We have also seen how to install Python and various ways to start working with Python. We gave an outline of various Python elements such as tokens and data types. In the next module, we will be explaining how to work with Python interpreter. Looking forward to see you in the next module. Thank you.